Hey everyone, there's a picture of David for you. And today we're going to be doing okay, wait, there's a picture of me too. My name's Elaine, and that's David. And we're going to be doing implicit differentiation for you because math is super fun and super awesome, and everyone should love it.
Alright, so why do we need implicit differentiation? Well, there are two types of equations, explicit and implicit. So explicit is the stuff we're used to, where we just solve for one variable. So an example here, we would just solve for x. So that's pretty easy, but with implicit differentiation, it's kind of harder. We gotta solve for two variables, so we gotta solve for an x and a y, and that's kind of where it kind of gets complicated there. Alright, so a good example of this is when we have to solve for a circle. So with the equation x squared plus y squared equals 25 at x equals 2, we find out that there's more than one answer. So when we draw the circle at 2, there's not just one slope, but two slopes. Oh no, that's crazy. So that's where we would use implicit differentiation, and by that we need to derive um, for more than just the one variable like we usually do. So with derive in terms of both x and y. Alright, to derive with an x, we just do what we usually do, derivative of x over x, which is just equal to 1, so we cancel those out. But with a y, it kind of gets more complicated. So we derive it, but we do dy over dx, derivative of y with respect to x.
Lucky for all of us, implicit differentiation can be solved in 4 easy steps. Well, first we need an equation. I think that a good equation is x squared minus 5xy plus 3y squared equals 7 because it has two variables. Oh no! This is when we use our little steps. Okay, so the step one is to take the derivative, um, and you use dx for x variables and dy dx for y variables. Now, the thing with y variables is that the AP test likes to trick you up, and it can be written as y prime on the AP test, so you have to be on the lookout for that. So now we do that step. So we have 2x dx, and then we have the product rule up here. Cute little thing. So we have to do our vu prime plus uv prime. So we're going to have our v's and our u's in first because we don't have to derive anything, and then we put our u prime with dx and our v prime with dy dx, and then we don't have enough space, so we have to do 6y dy dx equals 0 because the derivative of a constant is 0. Now we're going to simplify a little bit because dx equals 0, and then we're going to write it down more simplified. And then our next step is to isolate the dy dx because our main goal here is to find the slope. So we can move 2x minus 5y over to the other side, just using simple addition and subtraction. And now we can use the nifty algebra rule where dy dx can go in the outside parentheses and 5x plus 6y can go on the inside of parentheses, and then you just divide by 5x plus 6y, and you get dy dx equals negative 2x plus 5y over 5x plus 6y. At this point, you have the slope at any given point on the graph. If you're given a certain point, you just plug in the x and y variables into the equation, and there you have it.